Hello and welcome to this video on the top 10 most influential scientific discoveries of all time. First up, we have the theory of evolution by natural selection. This is the idea that species evolve and change over time through the process of natural selection, in which the fittest individuals are more likely to survive and reproduce. This theory, proposed by Charles Darwin and Alfred Russel Wallace in the mid-19th century, has been supported by overwhelming scientific evidence and has had a profound impact on our understanding of the diversity of life on Earth and the relationships between different species. Next, we have the structure of DNA. In 1953, James Watson and Francis Crick discovered the double helix structure of DNA, which revolutionized our understanding of genetics and inheritance. DNA is the molecule that contains the genetic instructions for the development and function of all living organisms, and the discovery of its structure provided the foundation for the field of molecular biology. It also led to the development of DNA sequencing and gene editing technologies, which have had a wide range of applications in areas such as medicine, agriculture, and forensic science. Third on the list are the laws of thermodynamics. These laws describe the relationships between heat, work, and energy, and have wide-ranging applications in fields such as physics, engineering, and biology. The first law, also known as the law of energy conservation, states that energy cannot be created or destroyed, only converted from one form to another. The second law states that the total entropy, a measure of the disorder or randomness in a system, of a closed system always increases over time, meaning that energy tends to flow from hotter to cooler objects. These laws have important implications for the behavior of systems ranging from engines and refrigerators to living organisms. Number 4 is the theory of relativity. Einstein's theory of relativity, which includes the special and general theories, revolutionized our understanding of space and time and has had a profound impact on many areas of science. The special theory of relativity, published in 1905, describes the behavior of objects moving at a constant speed in a straight line, and showed that the laws of physics are the same for all observers, regardless of their relative motion. The general theory of relativity, published in 1915, describes the behavior of objects in a gravitational field and showed that gravity is not a force, but rather the curvature of spacetime caused by the presence of matter or energy. At number 5, we have the discovery of the Higgs boson. The Higgs boson is a particle that was predicted by the Standard Model of Particle Physics, and its discovery in 2012 confirmed our understanding of how particles acquire mass. The Standard Model is a theory that describes the fundamental particles that make up the universe and the forces that govern their interactions. The Higgs boson is named after physicist Peter Higgs, who proposed its existence in 1964. Its discovery was the culmination of decades of research and required the construction of the Large Hadron Collider, a giant particle accelerator located near Geneva, Switzerland. Sixth on the list is the discovery of the electron. In 1897, J. Thomson discovered the electron, which revolutionized our understanding of the nature of matter and opened up new areas of research in chemistry and physics. Prior to this discovery, it was thought that atoms were indivisible units of matter. The discovery of the electron showed that atoms are made up of smaller particles, and led to the development of the modern atomic model, in which electrons are arranged in shells around a positively charged nucleus. At number 7, we have the development of quantum mechanics. Quantum mechanics is a theory that describes the behavior of matter and energy at the atomic and subatomic level, and has had a profound impact on our understanding of the fundamental nature of the universe. The theory was developed in the early 20th century by physicists such as Max Planck, Albert Einstein, and Niels Bohr, and it differs from classical mechanics, which describes the behavior of macroscopic objects, in that it allows for the existence of phenomena such as superposition, the ability of a system to be in multiple states at the same time, and entanglement, the ability of two particles to instantaneously affect each other's state, even if they are separated by large distances. Quantum mechanics has had a wide range of applications, including in the development of technologies such as transistors and lasers. At number 8, we have the discovery of the structure of the solar system. The discovery that the solar system is made up of planets orbiting the Sun, rather than the Sun orbiting the Earth, had a major impact on our understanding of the cosmos. This discovery was made possible by the development of telescopes, which allowed astronomers to study the movements of celestial objects in greater detail. The heliocentric model of the solar system, proposed by Nicholas Copernicus in the 16th century and refined over time by other scientists, marked a major shift in our understanding of the universe and challenged the long-held belief in a geocentric, earth-centered, model. The discovery of the structure of the solar system also provided the foundation for our understanding of planetary motion and has had a wide-ranging impact on fields such as astronomy, physics, and mathematics. At number 9, we have the development of the scientific method. The scientific method is a systematic way of collecting and analyzing evidence to test hypotheses and theories. It involves making observations, formulating a hypothesis to explain those observations, testing the hypothesis through experimentation or other methods, and drawing conclusions based on the results. The scientific method has played a crucial role in the development of scientific knowledge and has had a wide-ranging impact on many fields. It has also helped to establish a common framework for scientific research and has helped to ensure that scientific findings are reliable and objective. The scientific method is based on the principle of empiricism, which states that knowledge should be based on observation and experimentation, rather than on tradition or authority. It also involves the use of logical reasoning and skepticism to evaluate evidence and to ensure that hypotheses are well supported. The scientific method has helped to advance our understanding of the natural world and has had a major impact on the way we think about and study the universe. Finally, at number 10, we have the discovery of the antibiotic penicillin. The discovery of penicillin, the first antibiotic, in 1928 revolutionized the field of medicine and has saved countless lives. Penicillin is a type of fungus that produces a substance that is toxic to bacteria, and its discovery by Alexander Fleming led to the development of a range of antibiotics that are used to treat a wide variety of infections. The discovery of penicillin marked the beginning of the modern era of antibiotics and has had a major impact on public health and medicine. It has also led to the development of new drugs and treatments for other diseases, and has contributed to the dramatic increase in life expectancy that has occurred over the past century. That concludes our list of the top 10 most influential scientific discoveries of all time. Thank you for watching. Don't forget to subscribe for everyday knowledge.